Okay, so this video is just going to be a continuation on the lesson series. So might take a little bit longer of a video. If you want a shorter tutorial, then you can go to my YouTube page, or you can, if you're at my web page, you can just click obviously on the video directly next to this one. So this is going to be a continuation of the solving equations. So this one's going to be on multi-step equations. The first one we did was on one step and two step. So now, when we did one step and two step, all of this information that I currently have filled in here, all right, that is what we talked about. So in that one step, two step, there is a lot of really core ideas and concepts that you need to understand to be able to solve equations. And now all we're going to do is now we're going to add some other properties into our equations that we're going to have to use. And that's all a multi-step equation just simply becomes. So how do we make these harder? Well, we just add some additional properties in. And some of these additional properties are these ideas of these new core concepts. So my new core concepts that we're going to talk about in this video are going to be this idea of algebraic quantities. What are they? And what do I do if I come into contact with some algebraic quantities? So what you do here is actually pretty simple. So an algebraic quantity is no other than associating things together and saying that these two things belong together and that they must be together until I start doing mathematical operations to then separate them. And that's all they are. But the initial aspect of them is that they are grouped together initially. So how do we group things together? Well, in mathematics, the ones that we are going to deal with for this particular level are going to be basic ones. The ones that we're going to deal with are your basic grouping symbols, which are parentheses. So you have parentheses, and then the other thing that you have here are brackets. All right, which we probably won't in this video even get into brackets, but we will get into the last one, which is a fraction. So what's important here is you need to understand that fractions are actually grouping symbols. They are grouping a numerator and they are grouping a denominator and asking you how does the numerator and denominator, okay, act together. So the notation for these things, okay, parentheses are there's just a rounded curvature, parentheses, yes. And then brackets are going to look a lot like parentheses, except they're just going to be squared. Okay, so if you have those, they act the same way as parentheses. Okay, they're just still grouping symbols. And then the fraction, you've got this fraction bar. Okay, so the fraction bar is actually the thing that separates numerator and denominator. So here we go. There are some basic rules we need to follow if we come across these things of grouping symbols. So what's very, very important is that all grouping symbols are bound by three operations. The three operations that they are bound by are going to be multiplication. So that means if I have multiplication, okay, being applied to my quantity, that group is bound together until I do a property that allows me to ungroup them. Okay? The other thing is division, okay? And if you take a look up there at the top, well, guess what? Fractions are just another way of writing division. So division also bounds things. And then the last thing, which we're not going to talk about in this video, we're not going to get there, are going to be these things of exponents, okay? These are things you'll study later in Algebra 1. All right, you won't even study those in your pre-algebra course other than simplifying, but you won't study exponents on a quantity. All right, so that's what I mean. So now this idea of bounded, right? So I just use this word bounded. It means stuck together. All right, so if you have multiplication happening to a parenthesis, which means you see parenthesis in a multiplication symbol, all right, in between them, they're bound together. You cannot remove those parentheses unless you do some sort of algebraic property. All right. So that's an extremely, extremely important idea. I'm going to hit this again, that parentheses, brackets, fractions, they are bound by multiplication, division, and exponents. For us, we are going to be dealing with just the first two in this video, which is multiplication, division. So if I'm telling you that groups are bound by multiplication and division, well then how on earth do I get multiplication to go away? How do I get the division to go away? All right. So that is now what this video is going to do. We're going to talk about how we do that. Okay, so the first mathematical property that we're going to take a look at is called the distributive property. Now, the distributive property is a property of multiplication. So this is going to be our first, look at operations that deal with what binds a group of parentheses. And that is through multiplication. And that property is called distributive property. So it does that, So how do we remove it? We remove it actually through the definition of multiplication. And the definition of multiplication is the, repeated addition, of a quantity. So the number that is in front of the quantity is how many times we are going to add that quantity to itself. Now, the distributive property is nice because what the distributive property is going to come along and do is the distributive property is going to come along and make that process much shorter. So for the first one, I will demonstrate the longer, and then thereafter that, I'm just going to use the distributive property to make some things a little bit shorter. I'm also going to mix in there some other things that we have to take a look at in case this situation were to arise. So here we go. Number one. Number one says 5 times the quantity. Why am I saying the word quantity? Because I have a grouping symbol, and quantities are represented by parentheses, So algebraic quantities. So 5 times the quantity of x minus 1. So what I am now saying is that this 5 right there is telling me that I need to take this group and add it to itself 5 times. Now, parentheses will now no longer be needed. All I need to make sure that I do is I write that group, put a plus, add that group, put a plus, add that group, put a plus, So I'm going to do that 5 times. So I go x minus 1, then plus x minus 1, plus x minus 1, there's 3, plus x minus 1, there's 4, plus x minus 1. There is that group added to itself, and we have 5 of that group, So the 5 represents how many of that group you need to have added to itself. Now what you're going to go ahead and do is you're just going to go through and combine like terms. So combining like terms is looking for variables that are the same or looking for constants, and constants are just numbers without variables. So here we go. My first pair of like terms is I have x, I have x, I have x, I have a positive x, and a positive x. So what I've got here is I've got 5 positive x's, which gives me a total of 5 x's. So now I have 5x. Then I'm going to go ahead and take a look at the other things, which are the constants. So I have a positive, a negative 1, a negative 1. So if you notice, I have 5 negative 1s. Well, if you take negative 1 and subtract it and subtract it and subtract it, you end up getting negative 5. So this leaves me with minus 5. So now there is a much shorter way of getting to this answer, as opposed to writing this whole thing out. All right. So if I'm constantly having to do that, that distributive property doesn't make this simpler. It actually makes it longer and makes it more complicated. So we want to talk about how could I bypass this and get directly from here to that answer. And the way that you do that is, if you notice, all I have to look at is that the thing on the inside was duplicated. Well, how many times did I write it? You wrote it 5 times. And then the negative 1, how many times did I write it? I wrote it 5 times. So that right there is when you first learn your multiplication tables. It's literally just saying to you, how many times are you going to write that group? And then you multiply the two things together. And that's all it is. So distributive property, what it allows you to do is it allows you to recycle, the important piece that I'm going to talk about here, it allows you to recycle that 5. And it allows you to use it as many times as you have things on the inside. So what that means is, if you notice, in the group, I have 2 things. So what I'm allowed to do is I'm allowed to use this 5 right here twice. I use it for the first time to multiply it by x, and then I use it the second time to multiply it by negative 1. So now, a couple of things that are important. In front of this x, you do need to know that in front of every variable that does not have a coefficient showing, it is always 1. All right. The reason we don't put a 1 there is because I could look at that thing and go, how many x's are there? Well, there's only 1, right? So unless there's more than 1 x, I need to put a number, right? If not, I don't need to, because there's just 1. So moving forward, let's just show this. So 5 times 1x is that 5x. 5 times that negative 1 is negative 5, and voila, I've got a much quicker way of getting that value. So on the number 2, just to do some practice with these, negative 2 times x is negative 2x, because negative 2 times positive 1 is negative 2. And then negative 2 times negative 4, okay, and negative times a negative is a positive, so that's positive 8. And then there is the distributive property, okay? Moving on to number 3. Number 3 has 1/2. So again, what I want to point out to you is that this works, okay, with fractions as well. It doesn't matter. What we're looking at is the operation that connects the number to the parenthesis. If a number is right next to a parenthesis on the outside, it is always connected via multiplication. So I can use half twice because there are 2 things in the interior of that group. So I take 1/2 of 4, half of 4 is 2x, and I take 1/2 of 8, which is positive 4. Okay, and there you go. Now, moving on to number 4. Number 4 is a common one that you see, all right? But there's a common mistake that people make. And the common mistake that people make is they try to add this 5 and that 2, and then they try to use that and multiply that, okay, by that group. The problem is I don't want 2 plus 5 of that group. I am clearly going to tell you whenever these distributive property problems, all right, I am going to tell you specifically how much of that group I want right from the get-go, all right? And what I want right from the get-go is I want 5 of that group. Now, another reason, all right, that you should know that you should never add that is because that 5 has multiplication connected to it. And via order of operations, you always do multiplications first, okay? You never do additions before multiplications, all right? So what I'm going to do is I'm going to do the distributive property first. So that 5, I'm going to use it and multiply it by the 3x. And then that 5, and I'm going to multiply that in. Now, most people tell you to drop the 2 down right away. I'm going to drop that down second. All right? So 5 times 3x is 15x. All right? And the 5 times the negative 1, okay, is negative 5. Now, when I drop the 2 down, okay, at this point, what I'm going to go back and do, because I'm about to place something in front of that 15, all right, that is a positive 15, and then I'll put the 2 in front. So that's just something I do. If you want to drop the 2 down, drop the 2 down. That's just something different that I do, okay? And you'll see why I do it maybe on the next example, all right? So here we go, moving forward. So now I need to combine like terms. I need to take this 2 after the fact and combine it with that negative 5. So now I get 15x minus 3. All right, so now we're starting to build, not only doing distributive property, but combining it with maybe some like terms. All right, so then we continue on. So again, common mistake that you don't want to make is you always want to take care of the distributive property first. All right, you want to take care of those multiplications first. All right, so here we go. 3 times the group, okay, the quantity of x minus 1. Now, here's a big problem, all right? You need to remember, going back to my previous videos of talking about when we solved one-step or two-step equations, I highly suggest this. You should always write, when you have a distributive property problem, you see this negative out front, that you should always convert into what we talked about before of its opposite. So doing plus a negative 3. All right, that's how you should be thinking of this problem. All right, so I am a fan of rewriting this expression as 4 plus negative 3 parenthesis x minus 1. I like to take that extra step because then I remind myself this is a negative 3. All right, so negative 3 times x is negative 3x. Negative 3 times negative 1 is positive 3. Don't forget that you're distributing a negative along with that 3, okay? So now, the next thing I'm going to do is this 4 plus, I'll drop it right down, so 4 plus, and I understand that I have 4 plus negative 3, but at this point, what I would do is maybe with my little eraser, a positive and a negative is going to just make it into subtraction, okay? So now what I've got, all right, now I got to combine like terms again, all right? Now, some of you may just leave it there. Right? There's nothing wrong with that. 4 plus negative 3, okay? So that negative 3x has no like terms, so I'm actually going to write that right down here from the get-go. Negative 3x. I'm going to get it out of the problem and out of my sight. Okay, so that is now taken care of. So now what I've got is a 4 and a positive 3, which makes positive 7. Okay, so there's my final answer for that one. Now, last but not least, I just want to point out for this problem, I'm not going to do it for the sake of this video, but I do want to point out to you that it even works for decimals, okay? So the distributive property works based off of the operation, not off the type of number it is. So that's what it means, okay? So yes, I would take this 3.2, multiply it by the 5.4, and I would take this 3.2 and multiply it by the negative 1.3. So it works regardless of what the number is. I just want to point that out to you. But for the sake of this video, I'm not going to do it. You can get out a calculator and do it if you want. I want to move on to the next type of problem that we would have here, okay? So the next type of property that we would have here, okay, for solving multi-step equations is going to be the inverse property of multiplication. All right? So again, this is a property of multiplication. Okay, used to clear a fraction bar. To unbound a quantity that was bound by division. All right, so now what I'm talking about here is we're going to use multiplication to actually unbind division, right? So what I'm going to talk about here is determine what value must be used to clear the fraction bar. Well, you have to take a look at what's going on, okay? It's more than just looking at the denominator, all right? You could do that, but I'm a fan of clearing as much of the problem as you can as possible, all right? So notice that this x plus 5, it is bound by dividing by 4. So that means what I can do, all right, is I can simply just multiply by 4. Now, why can I do that? Well, if you notice, how many groups of x plus 5 are up there? Well, if there's no parentheses, all right, if there's no parentheses in the fraction, that means that there is one group up there, okay? So there is one group up there. Now, this is going to go back. If you watched my previous video on the 1 and 2 step, if you notice, I now have 1 over 4. Well, if I want to clear this fraction, then that means I would be multiplying by 4 over 1. And that's the value that I would use so that I could clear this fraction bar, okay? Number 8. Okay, what I would use here again is going to be this idea of the reciprocal, okay? And if you watch like I said, my videos before, I talk a lot about this idea of the reciprocal. So in this case, I would take and I would use the reciprocal. So notice this 3 is out front. I would use that 3 and I would use that 7, and I actually would multiply by 7 over 3, okay? And that's the value I would use to clear out that fraction bar. Now, I will say this to you, that you do only need to use at the utmost the bottom number. So I could use 7 over 1, and that would likewise get rid of the fraction bar. It won't get rid of the 3 though, okay? So it won't take care of your 3 when we start using these in equations, okay? So, but for right now, we're just getting the idea of, because we're about to do some practice with equations that have fraction bars in them, all right? And so now on to number 9. In number 9, what I would do, okay, is you could do 2 steps here, all right? You could multiply by 10, or you could multiply by 10 over negative 1, all right? So notice there was a negative up here. Negative next to anything is going to be a negative 1, all right? So there's that. Those are my values. So that's just the idea of what I would use. And I'm only going to use these, right? So now this is a very limited thing, right? I'm only going to use this step that I'm talking about, the value that I want for clearing the fraction bar in an equation. Know that this problem or this whole video is dealing with equations. So I'm just building up and setting up my mind for what value I'm going to need to use if I were in an equation, okay? Do not try to apply this to things that aren't equations, because you can't do that, okay? Just to make that clear. All right, so let's go ahead and practice these. So, solving multi-step equations. So we're going to take some things with distributive property, and we're going to take some stuff with good old fraction bars. So here we go. We're going to start solving multi-step equations. Now, the first thing that I take a look at for number 10, it says 7 times the quantity of x minus 5 plus 15 equals 71. So there's a couple of ways I could actually do this problem. And the thing that I'm a fan of, I am always a fan, okay, of removing anything around my multiplication that doesn't need to be there. Because remember, the goal is going to be to get this thing by itself. So in this problem, what I'm going to do is I am actually going to remove this 15 first. Why? Because I can. Now, do you have to? No, all right? I am just a person, right? I've done this long enough that I know, why not just get that 15 out of Dodge? So minus 15, minus 15. And what I'm left with is 7 times the quantity of x minus 5 is now going to be equivalent to 71 minus 15, which is good old 56. All right, that's 56. So moving on from here, what I'm going to do is now I'm going to do distributive property, because now I've isolated it to the point where I have this thing all by itself. Because I'm in an equation, all right, that minus 15 piece was legitimate. So now basically what I've got is just this side of distributive property, and we talked about distributive property. It allows me to use this number, okay, as many times as I have on things on the inside. So I'm going to take that 7 and multiply the first thing, and then take that 7 and multiply the second thing. So here I go, 7 and there. So here we go. 7 times 1x is 7x, and 7 times negative 5 is negative 35, which now is equivalent to 56. So from here, I'm now back to those two-step equations that I had from the very get-go, okay? So if you didn't watch my first video, I would say to you that if you're lost at this point in time, or you're not going to know what to do from here, I would take a minute and go look at my other video and get that problem. So here we go. We're going to go ahead and do this problem now. So now I take 56 and I'm going to add to it 35. Add to it 35. So 56 plus that 35 makes good old 91. So I get 7x equals 91. And then from here, what I'm going to do is I'm going to divide by 7, okay? Or what I'm more of a fan of is multiplying by the reciprocal. So I'm a fan, if you watched my first video, I really like to multiply by reciprocals. All right, so 7 times 1/7 will make this side 1x. And I multiply this side by 1/7, all right? Because now that I get that, so 1/7, okay, of 91 is good old 13. So now I have my answer. Now, if you didn't like what I just did there, all right, and you're watching my video, I just want to point out to you, you didn't have to use multiplication by the reciprocal. I just use it because I teach higher level classes where I use that all the time. So the point is, if you wanted to, you could have just used the division bar and you still get the same thing as x over 13, whichever it is you want to use, okay? So on to number 11. Okay, so on to number 11. So in number 11, just to point out to you again, okay, we have the distributive property, but I also have this positive 6 here, right? Okay, so I like to put the positive sign in front of it because I'm a fan of removing things that I don't need, all right? So I want to get that positive 6 out of there first, so I'm just going to go ahead and do it. You can hold on to it and combine it later and then move it, but I'm just going to move it now just because I want to get this distributive property thing by itself, because that's just what I like to do. So a positive 6. If you're in an equation, how do I remove this positive 6? That positive 6 gets removed by the inverse property of addition, which is adding its opposite. So if I add its opposite, it's adding a negative 6, which is the same thing as minus 6. So this side becomes 0, minus 6 over here. And now just be careful, just because I chopped that 6 off doesn't mean I got rid of that negative. That negative has to stay, because remember, that minus sign is the same thing as plus negative 2/3. So you can't just make that 2/3 into a positive simply because you got rid of a 6. Okay, I hope that makes sense. So this is going to be a negative 2/3 times the quantity of x plus 12 is equivalent to 8 minus 6, which is 2. Okay, so then we move forward. So now, like I talked about before, distributive property applies to all real numbers. So just because this is a fraction doesn't mean I can't use the distributive property, so I'm going to go ahead and use it. So negative 2/3 times x and negative 2/3 times 12. So negative 2/3 times x is negative 2/3 x. And negative 2/3 times 12 is good old negative 8, and that is equivalent to 2. So now from here, I'm just back to the two steps that I talked about in the first part of this series. So I'm going to go ahead and add 8 because I'm adding the inverse of, okay, of negative 8, which is positive 8. So I add 8 to both sides. I get negative 2/3 x is equivalent to 10. And now at this point, because I do have a fraction, I am not going to divide by a fraction. I am going to multiply by the reciprocal. So negative 3/2. So remember, any number multiplied by its reciprocal is 1. So that makes x. And then I go to the other side and I multiply by negative 3/2, which makes the answer negative 15. All right. So from here, I go on to the next type of problem. So now we have another problem here, number 12. So notice I have a fraction. Okay, so if you just watched the first part of this video and you didn't skip over this piece, I am a fan of still multiplying by the reciprocal. So what I'm going to do here, okay, is I'm not just going to multiply by 2, and I'm not going to break this down into baby steps, right? I'm going to start using some more powerful operations in mathematics to help me do things quicker. And one of the things that make me do things quicker is that if you notice, I could just slide this 2 over, and now I have 3 halves. So what I'm going to do, okay, is I'm going to go ahead, all right, and I'm going to multiply by 2/3. All right, so multiply both sides by 2/3. And once I do that, notice I now only have one group of 4x minus 6. So this whole side, because I used the reciprocal and I used the power of that, became just 4x minus 6, because that 3 and this 3 become 1, and that 2 and that 2, okay? So I get 4x minus 6 now equals 2/3 of 15. So 2/3 of 15 is just 10. So from here, I go ahead and I just start solving this. So plus 6 using the inverse property of addition. So if I have a negative, which means to make 0, I add the opposite, which is positive 6. So add 6, and I'm now left with 4x equals 16. Divide by 4 or multiply by the reciprocal. In this case, I'll show the division, okay, just to give some spice to this video. So x equals 4. So now I'm go ahead and I'm done. All right, so number 13. So number 13, this is an interesting one, okay? Number 13 is interesting for one reason and one reason only. So before, when I was talking about number 10, how I had the option of removing this 15, or I had the option of removing this 6, when you have a fraction, you no longer have the option of not removing this. If you don't remove this, you're actually going to make it a lot more work for yourself. So here's the deal. I am going to remove this one first because it's going to make less work if I get rid of things outside of the fraction bar onto one side and then deal with removing the fraction thereafter. So I'm going to do that first. So the first thing I'm going to go ahead and do is I'm going to get rid of the positive 6 by adding its opposite, which is a negative 6 and a negative 6. Now, that leaves me with 9x plus 4 all over negative 2, and that is now equivalent to 7. So, in the last one, notice that I multiplied by the reciprocal. And what I want to point out to you here is the only reason that I could use 2/3 is for a particular reason. And that has to do with, where was that 3? That 3 was not with that x, okay? That 3 was outside of parentheses. So in this case, I am not going to use multiplication by the reciprocal of 9. All right, I'm not going to use a 9 in there. Don't think you can use that. The only way that you can use these things is if they're connected through multiplication. All right, so that's an important idea about reciprocals. There are properties of multiplication. So that 9 is attached to that x through multiplication, but it's also grouped with that 4. I can't remove it from that 4. That's an important piece about the quantities, right? So anyhow, let me get back to this problem here and finish it off. So in this case, what I'm going to do, all right, is I'm going to use the opposite. So I'm going to take this, the negative 2, and I'm just going to multiply both sides by negative 2. So multiply it by negative 2, and there's only one group of this up top, so I'll flip it to a 1, right? So does that make sense, I hope? So I put that group in parentheses that weren't there, and if there was no parentheses, I put a 1 outside, and then you can multiply by the reciprocal there. So this is just 7 times negative 2 over 1. You can write the fraction, you don't have to write the fraction. It's up to you there. Okay, so now I'm left with this whole side is that all of this stuff now goes away because it all reduces to 1, and I get 9x plus 4 is equivalent to 7 times negative 2, which is negative 14. And then I can continue on from here. I'm back to the 2-step part, which is the back to that beginning process, which is minus 4, and I get 9x is now equivalent to negative 18. And then the last thing I can do here is divide by 9, and I get x is equivalent to negative 2. All right, so I have 2 more problems here, okay, because they deal with something a little bit different that I haven't dealt with yet. And I haven't dealt with what if the outside number, okay, isn't just a number, let's say it's a variable. Well, in 14, okay, I have that. So before, when I was talking about this number out here was actually just a number. So therefore, I moved it over here. Well, in this case, I don't want to do that because what I'm going to need to do is I'm going to need to take this x and after I do the distributive property to break these parentheses off, then I'm going to want to combine my new total of x's with this group of x. All right, so therefore moving this over here would actually make more work for me. Okay, so in this case, I'm actually going to do the distributive property first, and I'm just going to have to deal with that negative 7x being there. So here we go. So the 5, use it, and I get 10x. The 5 plus 8 is positive 40, and then I write minus 7x equals 58. Okay, so then from here, what I'm going to do is I'm going to combine like terms. My like terms are my 10x and my negative 7x, which makes a positive 3x, plus 40 is equivalent to 58. And then from here, I'm back to the 2 steps, right? So minus 40, and I get 3x equals 18. And at this point, you can multiply by 1/3, or you can divide by 3. At this point, you should probably choose what is helping you get through the problem. But do know that the reciprocal is a much more powerful operation to remember for later use. So that's why I like to use it. So multiply by 1/3. So 3 and 1/3 are reciprocals. So I get x equals 1/3 of 18 is just the number 6. Okay. So on to number 15. So number 15. So again, notice that I have the 4x here. All right. But that 4x is going to stay there. However, this 7, I'm going to move it right away. I don't need it on this side. It doesn't serve any purpose. So I'm going to go ahead and actually subtract 7 from both sides. And I'm going to be left with 2 parentheses, negative 3x, minus 15 plus 4x is equivalent to 42. So from here, okay, what I can do is that now I can do that distributive property problem. And the reason I kept that 4x was simply because I know that I'm going to have to combine my x's to be on one side, okay, with the new x's that I create. All right, this 7 needs to eventually go with all numbers, which needs to go on the opposite side of the x's. So why not just put it there to begin with? Why deal with it? Why try to combine it, then move a higher number, okay? So I'm just moving it first. 49 minus 7 is going to be much easier than whatever I come up with next, okay? So here we go. Now I go ahead and do my distributive property. So 2 times the negative 3, which makes a negative 6x. 2 times the negative 15 makes a negative 30, plus 4x is equivalent to 42. And then from here, I'm just going to combine like terms first. So I get my negative 2x, because negative 6 and a positive 4 makes negative 2, minus 30 equals 42. And now again, I'm back to the first part of the series that I talked about, which is the 2-step equations. So now I'm going to add 30 because the inverse operation tells me to add the opposite. So I get plus 30. And now I'm left with negative 2x is equivalent to 72. Divide by negative 2 or multiply by negative 1/2. This time I'll just show the division way. So divide by negative 2 and I get x equals negative 36. And there you go. There you have it. I'm done. I've shown hopefully a good examples. If there's something on this video that I didn't hit on or didn't show you that you need and need more explanation on, please just leave a comment down below and I'll do my best to make a video for you and come up with some more example problems. All right? So have a good one.